Engine repair 2 test 13 is where we are today. That's from cylinder head service. We were just talking about cylinder heads a few minutes ago before we got started here. And the cylinder head is the part of the engine that forms the upper part of the combustion chamber. It's got the valves in it typically, unless it's a flat head. And it's that the air comes in. There's cross flow cylinder heads where the air comes in one side and go out the other. And then there's cylinder heads where the air comes in and goes out the same side of the head. Right? Like if you've got some of these, a lot of these 4-cylinder engines now, most of them, the intake air comes in. Does it come in the front or the back?
Back.
Could be either way. Some of it comes in the back, some of it comes in the front, right? Okay, so you got the cylinder head. Now, y'all pull the cylinder head off of that GMC out there, and you pull the cylinder head off because it had a blown gasket and it was pushing compression back and forth between cylinders. Which 2 cylinders was that? You remember? Remember which 2 numbers? Where's number 1 on a Chevrolet?
Left front.
Left front, and you pull the right hand cylinder head, so it's 2, 4, and 6, 2, 4, 6, 8 on that side. So between cylinders 4 and 6, the 2 center cylinders, gasket was blown. Cylinder heads with 4 valves flow more air than those with 2 valves because of what? They have a greater open area. They use a higher lift camshaft. They increase the velocity of air. Actually, it would be both A and C. How many of you guys have ever made homemade biscuits? You ever seen anybody do it? You roll the flour out and you take your glass and you poof, 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 you stamp out them things like that. All right, now, if I've got a round area like that, and I stamp out 2 biscuits out of that, you know, I might get 2 pretty good sized biscuits out of it. Let's just make one of them slightly bigger than the other because we're talking about valves. All right, so that looks pretty good, but we don't have as much area here as we would if we did this. If you took 2 like that and 2 like that. It's going to breathe better because there's going to be more air coming in. You got these 2 and these 2. You add the collective area of those, you're going to have more air on one of those. That's why you might remember me saying the other day that an overhead cam engine, particularly the ones with 4 valves, typically have compression that's probably 20 to 30 psi higher than a cam and block engine. Now some, well anyway, I don't want to get off on that. 2 technicians are discussing a Hemi engine. Now why do they call it Hemi? Anybody know? You see Hemi on the side of the car all the time. What makes a Hemi special? What's Hemi? What are you thinking of when I say Hemi? Well, yeah, sort of, but I mean, well, like the Dodge has got Hemi engines in them. Now, what makes a Hemi different from a regular engine?
More stronger.
Huh? What? Look at the combustion chamber. This is the block. Okay, the cylinder head on some of them, and I got a presentation on this, is kind of shaped like that, right? I mean, they got all different ways. You know, like on that Chevrolet you guys took apart, it's kind of like that, you know. I mean, if you look at the cylinder head, this part up here being a cylinder head, this is the block where the piston comes up. A Hemi, basically, is like that. Usually have the spark plug right in the middle, and it'll have valves here and here, but it'll have 4 valves per cylinder. So you got a hemispherical combustion chamber with these valves right here. I should have drawn them like that, opening and closing, and that is really a pretty good design. You know, big cross flow deal and all that kind of stuff. That's what a Hemi head means. Hemi is actually a hemispherical combustion chamber. Technician A says a Hemi engine is an engine with a hemispherical shaped combustion chamber. What did I just say? Okay. Technician B says all Hemi engines are cam and block designs. Now, what is the red flag when you're looking at one of these? If you see the words all, only, always, every,
They're usually wrong.
that's usually wrong. That's right. So this one right here, Technician A is going to be the one that's right on that one there. Now, Technician A says an Audi 5-valve engine uses 3 intake valves and 2 exhaust valves. Technician B says he uses 3 exhaust valves and 2 intake valves. which technician is correct about that? It's got 3 intake valves and 2 exhaust valves. Typically, you're going to have more area, bigger intake valves than exhaust. I mean, you can figure that one out. Because if you're going to have more of one than the other, you're typically going to have more intake than you are exhaust if you're going to have an odd number like that. Audi kind of likes that crazy stuff anyway. There's some of these Audis are kind of like have got 5-cylinder engines in them, or the old Volkswagen Quantums and the Audi Foxes and stuff, I guess. But we've also, some of your, let's see, we worked on an Acura Vigor. That was an early 90s model that had a 5-cylinder engine in it. But they like 5. For some reason, they got a 5 number they like. The gasket surface of a cylinder head is measured with a straight edge should have a maximum variation of what? Anybody know which one of those is right? I don't really like questions that's got all those numbers stacked in there. That's going to be A, 2/1000ths of an inch in any 6/6 length, or 4/1000ths inch overall. We were talking earlier about that straight edge. Put it across there, put your feeler gauge under there. I like to put it right under the middle. And there's some heavy duty measuring you're supposed to do there. But one way or another, you want to make doggone sure that thing's as flat as it can be. A warped aluminum cylinder head can be restored to useful service by doing what? You're not going to believe this answer. What about heating it in an oven at 500 degrees with shims under each end and allow it to cool and then machining it? That's right. What we used to do, I mean, there was a machinist that worked over at the Ford place over there. He worked at the Ford, at Bondi's Ford over in Dothan. We had a machine room where we machined cylinder heads and all that kind of stuff. It's a pretty big dealership. I don't know if they're still doing that over or not, but they used to have a machine room and a guy that just worked in there, and that's all he did was machine work, And he built from scratch an oven. And he actually used a metal brake, and he put a thermostat, and he got some heating elements and all that kind of thing. And he took a thick piece of steel, and he put it in his cylinder head machine, and he made it really, really pretty and flat in a cylinder head resurfacing machine. And then he took that piece of steel and he drilled it to fit these Escort cylinder heads, so that there was exactly, the holes were lined up perfectly, the exact same number of bolts and all that. And he would torque that thing down. He put threads in there on that, that the head bolts would fit. And he would torque that cylinder head down just naked to that piece of steel, just as tight as he could torque it, within specs and all that. And then he would put it in that oven, and he would crank that oven up to 500 or 600 degrees, and he would let it bake in there a while. I don't know how long. They'd let it come out, and then he would do this with cylinder heads that were warped beyond their useful limit. They were supposed to be discarded. And when he torqued that thing down, and then he took it out and machined it, it would be like a brand new cylinder head. Now, heating it up really, really hot like that also cleans it. You ever use a self-cleaning oven? You have an oven with splatters and stuff all in it, you know what I'm talking about? You turn it on self-cleaning, you turn it on to clean, and you don't open that door, and it goes up like 600 degrees, and whenever you open it up, it looks like a brand new oven in there. It's just really something how them self-cleaning ovens work. We got one. But anyway, that's what number 5 is. Number 5 is basically going to be heating it in an oven at 500 degrees with shims under each end, allows it to cool and then machine it. Some vehicle manufacturers recommend repairing an integral valve guides, and a valve guide is the part of the cylinder head that's my little 1-inch hole saw. Oh, how pleasant. Did you have a good time going over to Ace Hardware? Mm-hmm. Yeah. And people fix you a cup of coffee while you're over there?
No.
Why not? Surely they want you to come back.
Sure. They said thank you.
All right, then.
That was it.
I'm sure. All right. That's good. Let me see. Some vehicle manufacturers recommend repairing integral valve. In other words, that's valve guides that are made into the head. And that's D. Oversized stem valves. Basically how they do that. What they do is they bring it out a tiny size bigger and put oversized valve stems in there. This is something that machine shops typically do, cylinder head service. Now you can, if you're pinched or whatever, and you don't have a blatant valve problem, like when you're replacing some valve, like if somebody's bent some valves out of stupidity or whatever, and you have to get new valves, you can take some valve grinding compound and get in there and lap it. I like to put a drill on the valve, go zzz, 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 like that if the seat looks good and all that. Then I put some Prussian blue on it, and I slap it up there, and I make sure that it's got a good contact all the way around. And typically, that'll be good enough, You know, some people probably argue with that, but we're saving lives here, right? A typical intake valve system to guide clearance. Ooh, this is something you won't know unless you read the book with it. What do you think it would be? Typical intake valve stem to guide. Now, when I say, well, look at this. See this overhead I got down here? Now, there are no valves in this cylinder head. There are no valves in this cylinder head at all. You see these things sticking up right here. You see that? That's the valve guide. And the size of that hole is pretty important because you don't want that valve wallowing around and all that kind of stuff. That's what we're talking about when we're talking about valve guides. Now, some of them have replaceable valve guides, some of them don't, you know. The long and short of it is these right here are pretty darn important. There's actually a little, you know, these people that do cylinder head work really go overboard doing all this stuff. Holding that cylinder head's up, aggravating. Okay, let's see. Typical intake valve to stem guide clearance, and that's what I was talking about. You guys know what the valve stem is, right? Have I got a valve in here somewhere? Here's one. This is a burnt valve. We're going to see a burnt valve. This is the valve stem. All right, now that it goes up and down within that guide. You can actually run your fingers up and down this valve stem and you can feel where it was going up and down in its guide. And the seat of it is kind of burnt there. This one here was taken out because it was burned.
Is that the same one right here?
Huh? This one, oh yes, okay. This is bent.
Yeah.
This valve here is bent. See, as I turn it around, somebody done bent that one. But you notice the stems are two different sizes and all that, but that's what valves are. And a lot of them will be sodium filled. So if you grind in there and you get into that sodium, it'll go boom, it'll explode. So be careful about that. You probably already knew that, didn't you? Okay, you didn't know it. Okay. So basically on number 7, we're wanting it to be 1 to 4 thousandths of an inch, which would be 25 to 76 hundredths of a millimeter. Okay, if 1 millimeter is 40 thousandths of an inch, and I got an engine part that's 25 hundredths of a millimeter, how many thousandths of an inch is 25 hundredths of a millimeter? 25 hundredths of a millimeter equals how many thousandths of an inch? If 1 millimeter equals 40 thousandths. Can you pull that off the top of your head?
I wasn't really good at math.
1 millimeter is about 40 thousandths of an inch. It's real close, 40 thousandths of an inch. 25 hundredths of 1 millimeter is how many thousandths of an inch? You should have time to figure this out. Well, it's funny to me was I asked old Gene Taylor, he's a little bit older than me. He came in here and I asked him this, and within 5 seconds he spit the answer out. Think about it. 40 thousandths of an inch. Okay, y'all ruminate on that. Somebody give me the answer before the end of class. Do math or whatever. 1 millimeter equals 40 thousandths of an inch. 25 hundredths of 1 millimeter is how many thousandths of an inch?
25.
Bingo! Is 2,500? Yeah, 2,500 is what now? Is how many thousandths? Look at this. I probably should write this on board. I thought you were equal 4 to 0. I wrote it wrong. That equals 40. Okay. Now 0.25 millimeter equals how much of this? What's a fourth of this?
10.
That's right. 25 hundredths of a millimeter equals 10 thousandths. Right? If I can write that right. There you go. See there? That's how that works. Got it? Be able to pull that stuff up? I know how much you guys like math. Okay, what type of valve guide is most used in a cast iron head? Wait a minute, never mind. What other engine component may have to be machined if the cylinder heads are machined on a V-type engine? Intake manifold, believe it or not. Cause, why is that? The intake manifold, if you've got a block, here's your heads, right? Your intake manifold, if I drew that right, your intake manifold goes here, doesn't it? See there? There's your intake manifold. Now you can see that if you cut these heads down too much, you may have to machine the intake manifold off so that this will fit right. Because this won't fit right if you machine these too much, will it? Because you got holes that have to line up here and all that. So you may have to machine the manifold in order to make it fit if the heads have been machined very much. That's the answer to that question right there. What type of valve guide is most used in a cast iron cylinder head? That's valve guide. Integral. Now, the cylinder heads on the old Volkswagen Bugs had brass valve guides that were interchangeable. I mean, that were replaceable. And when my dad did a valve job on an old aluminum Volkswagen Bug head, this is how he would do. He would take he would run a 3/8 thread tap up in that valve guide, and then he would, after he cut the threads in there, he would screw a bolt in there, and he'd flip the head over, and he'd put a punch against that bolt and drive the valve guide out. And then he would take the replacement valve guides, which he kept in the freezer, and he would put them in there, and he would put something on them so he wouldn't mushroom them and whack them in there. And then he would have new valve guides in there. He could replace the valve guides, and he would do the seats, and he could even resurface cylinder heads on them things. And but I mean, valves have to have a valve guide, whether it's made in there or what. A lot of times they'll drill that out and put valve guides in there too. Which of these statements is? They also replace the seats with Stellite seats too. I mean, there were Stellite seats in there really, really hard. Which of these statements are true about surface finish? The rougher the surface, the higher the micro-inch finish measurement. Unless you have really special equipment, you're not supposed to be able to machine the cylinder heads on engines like Crown Victorias and some of these other ones nowadays because they are really, 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 really smooth. In a normally operating engine, intake and exhaust valves are opened by a cam and closed by what? Somebody better have an answer for me. What closes the valve, you guys?
Valve guides and push rods.
No, well, the spring, yeah, the spring closes it. The valve guides and push rods actually, the push rods open it in the rocker arms. If an interference angle is machined on a valve seat, the angle is usually what? Now, what's the interference angle? We'll talk about that for a second. How many of you guys have heard Joe Gearhead talking about a 3-angle valve job? You hang out with Joe Gearhead very much, you're going to hear him talking about a 3-angle valve job. This part of the valve is a ground. See that last little bit right there, the seat? That's ground. You need to understand this, right? Okay, now the valve seat, now this right here is going to change. It's going to go like that. Okay. This is the part that's ground. It usually has a slightly different, I'm not drawing it quite the way I should, but anyway, like that. Now the seat that it goes against is going to have 3 different angles on it. Now what you're wanting is you're basically wanting, let's zoom in on this. Everybody watch. Don't get bored and just go to sleep until I'm through drawing my picture because you need to know this. Let's zoom in on this. This is the valve seat, and this is the part that it seats against. We don't want those to be perfectly a match, but we do want them to be close. And so the difference between here and there, we want that to be 1 degree. Right? You got that? Are you about to go to sleep?
You want it to be what, 1 degree?
1 degree different. And that's how you want it to go. This being the margin of the valve, and this being the seat. Like that. You want it to be 1 degree. When that thing pulls, and what that's going to do is it's going to make that valve seat better and not be as likely to leak. You got it? You want it to be 1 degree. And that's how that's supposed to work. Let me see, and that's on number 12 is D, that's 1 degree. Never remove any more material from the tip of a valve. Now wait a minute, why would we be removing material from the tip of the valve? Because if we ground the seats and we ground the valves, it's going to come up a little farther, isn't it? And so we're going to have to take a little bit off here to keep that spacing the same, right? Now, not all valves can be adjusted, believe it or not. Anyway, it says, let me see, never remove any more material from the tip of a valve than how many inches? 20 thousandths of an inch is the most you're supposed to remove from the tip of that valve. All right, you got that? A valve should be discarded if the margin, now the margin, what did I say? Look at this, guys. This right here is the margin, right there. See that little plate? Matter of fact, you can see it on this valve here. and that one right there. They're not very, these margins aren't very thick. But that margin is what's between here and here. That's what that is. Okay, so let me see. It should be discarded if the margin is less than, be 30 thousandths actually. And if that's the case, you know, those two right there. Now, I don't know if all their specs are the same here. A valve seat should be concentric to the valve guide to a maximum total indicator run out. And what you do on that, you have a little dial indicator thing, and you're going to turn the valve like this, you know, and that dial indicator is going to tell you if the top of that valve is, you know, it's not regular, it's round, slightly out of round or whatever. So there's a little measurement on that. These measurements right here are pretty doggone dicey, and like I say, the machine shop people are what do this. You know, you're not typically going to, you the mechanic aren't typically going to do that. Now what we do that have done sometimes is we take cylinder heads and we turn them upside down with the valves up, and we, you know, prop them up so they'll be nice and level, and we pour something in there like alcohol or something and see if it will go past the valves and leak out. That's with the springs holding the valves closed, right? And that way you can see if there's any kind of little bit of leak there. See, because as this stuff starts going past, if this valve's not seated and it starts going past there, that's how it burns the valve, like you see that one there is, you know. Because it's like a torch, you know, it just keeps burning through there. So number 15 is going to be B, and that's 0.02 of an inch. To lower and narrow a valve seat that has been cut at a 45-degree angle, use a cutter or stone of what angle? Now you know, we got that stuff out there. This is 30 degrees. You got a 60, a 45, and a 30-degree angle. I mean, different angle rocks that you use. But you're actually gonna, the valve seat is the part in the head where the valve pulls against, basically. Valve spring inserts, shims, are designed to do what?
Adjust and control the valve spring install.
Adjust the correct valve spring install height. That's what you were saying, wasn't it? Okay. A proper relationship between intake and exhaust valve diameter. What is that? Exhaust valve size is 85% of intake valve size. Now, when we're talking about the diameter, we're talking about this. You know, if you look at a cylinder head, the biggest valves are going to be the intake valves. You're always going to see the biggest valves being the intake valves, right? You know, if it's a 4-cycle engine now, you know, Detroit diesel engine's 2-cycle. It's got 4 exhaust valves and no intake valves. Let me see. Now, dampers, damper springs inside. You know, sometimes you'll see valve springs that got a smaller spring on the inside of them. What are they for? They're supposed to prevent valve spring surge. Whenever somebody talks about fluting a valve, that's whenever they get it spinning so fast that the valve doesn't have time to close and the piston hits it. What?
What was 18.3?
That's going to be a C. All right. All right, everybody understand that?